you're looking at doing the integral from 0 to a of the upper function minus the lower function dx. Can someone tell me what a is equal to? Exactly?
No, it's rounded.
4, 8, what is it? 4, 8, 7, 6, what?
6, 4, 4.
Okay. What you want to do is that's what you literally want to write on your test. You do not round into. You only round at the end. You round at the end. You round at the end. You round at the end. Is there a digit off?
There's an 8 between the 4 and the 7.
Yeah. Yeah.
Between the 4 and the 7. Oh,
Or
8. Okay. Got it. Okay. So then you run this integral. Can someone tell me what the exact answer is? Someone raise their hand. And tell me what the proper answer should be. Daniel, what did you get?
I got 3.215.
215. Who agrees with 3.215? You are popular today. That sounds great.
But it was 3.2145, so you could have got 4.
Ah, so there are two possible answers to this, or 3.214. Correct. You can chop it off or round. Correct. They will list that. They'll accept both. My guess is this is easy 3 points. The setup is 2, and then the answer is 1. 10 point what?
149 pi.
Pi, like that?
Yes.
And they'll accept that or the decimal answer when you multiply by pi. Yes, either one. Record. Okay. So we know that that's when 3 minus x is equal to 0. So x is equal to 3. So there it is. Find the x-coordinate of the point of tangency. Did we just find it?
Yes.
We did. And determine whether f has a local minimum, maximum, or neither at that point. There are two ways you can determine whether something is a min or a max. How do you do it?
plug in values.
What are the name of the two tests? The
The first derivative
test and the second derivative test. Which one do you want to use?
Second.
Second derivative test? Okay, so if we're going to use the second derivative test, what do we need to find?
The second derivative.
We need to find the actual what?
Second derivative.
Second derivative. What do we have already? We have
The
the,
first derivative.
we have the, so once again, we do the second derivative with the implicit differentiation, and then we're just looking at whether the second derivative is positive or negative at that point. Make sense? Okay. Okay?
Yep.
Yeah, this is much better. Is this integration really straightforward?
Yep.
There's no natural logs, there's no absolute values. This is great. So what's the derivative, what's the integral on the left going to be?
Y.
No. Y squared over 2 equals what?
3x minus 1 half x squared.
And then what do we add on here?
Plus C.
There's a c on both sides, right?
Yep.
But we can combine them and make one constant. Do you agree with that? Okay, so now though, what are we interested in? What did it tell us in this problem? It told us g of 6 is equal to? G of 6 is equal to negative 4. So no, g of 6 is equal to? So when we plug in negative 4 for y, what does x equal? 6, right?
Mm-hmm.
So what are we solving for? So that's
C.
8 equals 18 minus what?
18.
Plus c, so c is equal to?
8.
8. So we now have the equation 1/2 y squared is equal to 3x minus 1/2 x squared plus what?
8.
Plus 8. That's not quite what they asked us for. We need what do we still have yet to do?
Y.
Y equals g of x. We need y in terms of x. We need y in terms of x. So what do we need to solve for?
Y.
So we know that y squared is equal to 6x minus x squared plus 16. I just multiplied by 2. Now, if we're going to isolate y, what do we have to do? Square root both sides. You get y equals plus or minus the square root of 6x minus x squared plus 16. We're close to done. You have to consider one last thing. Is that a function?
No.
No, it's plus or minus. How do we figure out which one we want?
Look at the domain.
They gave us a point, right? What did they tell us? When x is equal to 6, y is equal to?
Negative 4.
Negative 4. So which one are we going to take?
The negative root.
Yes, so that means take negative 1. So it's going to be y is equal to negative the square root of 6x minus x squared plus 16. How confident are we with that answer? I think we're pretty confident. Should we check our answer? I kind of want to do that.